Today we'll be showing the following identity between the eta and zeta function. And to start off, we will consider the series representation of the zeta function. So zeta s is the sum from 1 to infinity of 1 over k to the s. Now from here, I'm going to break apart the sum into its even and odd parts. So this will be the sum from 1 to infinity, 1 over 2k to the s power, and then plus the sum from 0 to infinity, 1 over 2k plus 1 to the s power. So is equal to the sum from 1 to infinity, 1 over 2 to the s times 1 over k to the s, and plus the sum from 0 to infinity, 1 over 2k plus 1 to the s power. So this means that zeta s, you can rewrite this as 2 to the negative s power, and the sum from 1 to infinity, 1 over k to the s, and then plus the sum from 0 to infinity, 1 over 2k plus 1 to the s. But this is just the zeta function. So you have zeta of s is 2 to the negative s zeta s plus the sum from 0 to infinity, 1 over 2k plus 1 to the s power. And now we'll solve for this term. So this means that zeta s and minus 2 to the negative s zeta s is the sum from 0 to infinity, 1 over 2k plus 1 to the s. So we'll hold on to this for now. And now we'll do the same thing but for the eta function. So eta of s is the sum from 1 to infinity, negative 1 to the k minus 1 over k to the s. So we'll do the same thing, break it into its even and odd components. So this is equal to the sum from 1 to infinity, negative 1 to the 2k minus 1 divided by 2k to the s power, plus the sum from 0 to infinity, negative 1 to the 2k plus 1 minus 1 over 2k plus 1 to the s power. So you have eta s is going to be the sum from 1 to infinity. We could break this apart into negative 1 to the 2k, negative 1 to the negative 1 over 2 to the s, k to the s, and then plus this cancels the sum from 0 to infinity, negative 1 to the 2k divided by 2k plus 1 to the s power. So you have eta s. We're going to have a 2 to the negative s term. We're going to have a negative sign. And negative 1 to the 2k will end up being 1 for any integer k. So you have the sum from 1 to infinity, 1 over k to the s. Same thing for this one, plus the sum from 0 to infinity, 1 over 2k plus 1 to the s power. So we have eta s is negative 2 to the negative s zeta s, and plus the sum from 0 to infinity, 1 over 2k plus 1 to the s power. But recall that our little star, that the sum from 0 to infinity, 1 over 2k plus 1 to the s, was defined to be zeta s minus 2 to the negative s zeta s. So now all we do is plug it into this equation. So you have eta s is negative 2 to the negative s zeta s, and then plus zeta s minus 2 to the negative s zeta s. But we can combine these two terms. We have that eta s is negative 2 to the negative s times 2 zeta s plus zeta s. So this will be negative 2 to the negative s plus 1 power zeta s plus zeta s. Factoring out a zeta s term, we have zeta s negative 2 to the negative s plus 1 and then a plus 1. So now we could say that therefore eta s is going to be 1 minus 2 to the 1 minus s times zeta s. And that is the identity we want to show. Thank you very much for watching.